Today I'll explain how to detect collision between a sphere and a ray. A sphere is an object represented by a radius, which determines its size, and a position, which indicates its location in the world. A ray is a mathematical construct. It is represented with a point of origin and a vector for direction. Rays are useful for testing collisions between such objects as a mouse cursor and a game object. They are used for line-of-sight testing for NPCs and edge-based collision detection. The IsRayIntersectingSphere function uses parameters for the origin of the ray and its direction. The distance to intersect reference is an output value, which represents the scalar distance between the ray's origin and the intersection point on the sphere. The intersect vector represents the closest position on the sphere the ray is intersecting with, assuming it is intersecting. The distance vector stores the distance between the origin of the ray and the position of the sphere. The direction normal creates a normalized version of the direction, which means its magnitude is 1 unit in length. We perform a dot product between the distance vector and the ray direction vector to ascertain whether intersection is possible. The distance squared calculation tells us whether the ray originates outside the sphere's radius. Using the dot product for the distance vector with itself is just self-multiplication in this instance. It's not a difference of direction calculation, as it usually is between two vectors. We do this to make it proportional to the radius, which is also squared. We could have taken the magnitude of the distance vector and subtracted the sphere's radius from it. However, this way allows us to avoid the expensive square root operation, which the magnitude function uses. If the squared distance is more than 0, the ray originates outside the sphere. If the dot product is less than 0, it is also pointing away from it, as you can see in the first example here. If this is the case, there is no intersection, so we return false. To explain the discriminant, we need to go over a bit of math. An algebraic equation is a mathematical statement equating two expressions. A polynomial is an expression with one or more terms, each of which consists of a constant, a number, multiplied by a variable, a letter, raised to a non-negative integer power. A term can also be just a constant, like the 4 in this example. A quadratic equation has expressions where the terms are raised to an integer power no higher than 2. The quadratic formula is one of several methods used to solve quadratic equations. The difference under the radical is called the discriminant. Because our ray direction has been normalized in our example, which means a is 1, we can use the simplified form. If the discriminant is positive, it means the ray intersected the sphere twice, once upon entry and once upon exit. If it is 0, it means it grazed the surface of the sphere. If it is negative, it did not intersect the sphere. If we reach this point in the function, the ray is intersecting the sphere, so we can calculate the distance to the intersection point, which is the scalar distance between the ray's origin and the closest intersection point on the sphere. If the distance to intersection is a negative value, it means the origin of the ray is within the sphere's radius, so we clamp it to 0, which shows a notable attribute of this function. We don't get the intersection point on the sphere if the ray starts within it. This function assumes the ray is starting from outside the sphere in most cases. We then offset the ray's direction vector by the distance and add it to the ray's origin to calculate the intersection point. Finally, we return true.